Hello and welcome to Unit 4 on quadratic expressions. Now, this unit's going to be slightly longer. It's going to span 4 days, so the rest of this week will be dedicated to Unit 4. So, because of that, we have a few more learning objectives here or learning goals. First off, I can expand and simplify second degree polynomial expressions. Then we'll move to I can factor polynomial expressions using a various amount of techniques. I can interpret real, non-real roots of quadratic equations. I can solve quadratic equations that have real roots by graphing, factoring, and using the quadratic formula. I can convert between standard form, vertex form, and factor form by using a variety of strategies. And I know the quadratic formula, and more importantly, I know how and when to use it. So that's what we'll be looking at over the next 4 days. But we're going to start off with a little bit of a refresher here. So, lesson 4.1's algebra and multiplying binomials. And one of the things that we will talk about is FOIL when we multiply two binomials. What do we do? And I mentioned this in a previous lesson, but we'll look at it in a little bit more detail today. Before we go to foiling, though, we're going to review exponent laws. So, if you've got the ability to take a snip, I recommend using the snip tool and just capture this photo here and save that and have it somewhere close by for when you're doing math. It's a nice little snapshot of all the exponent rules. We're not going to go through all these rules. We're going to go through only a few of them. So, consider the expression a squared times a cubed using the definition of exponentiation. A squared times a cubed, it's actually just a product law. And it states when we have two exponents that we're multiplying that have the same base, so we see a, that's the same base, we're just going to add the two exponents together. And so a squared times a cubed, we can simplify to a to the fifth power. Now, really, really important here, if the base is not the same, this rule does not apply. Cannot use this rule if the bases are not the same. So, for example, the expression 2 to the fourth times 3 squared cannot be combined. 2 and 3, which are bases, are not the same, so we can't combine them. So, product rule once again, if we have two exponents that have the same base and we're multiplying them, all we'll do is we're going to add the exponents together. So, we'll have the base and the added exponents. So, a to the x times a to the y equals ax plus y. Another one we can look at is the quotient rule. And that's when we're uh, dividing exponents with the same base. So here we have a cubed divided by a squared. And what the quotient rule tells us, it's the exact opposite of the product rule. We're going to subtract our exponents. So we'll take the exponent in our numerator, subtract the exponent in our denominator, and we're just going to have the same common base. So a cubed divided by a squared will be a, and then 3 minus 2 is going to give us 1, so a to the 1. You don't have to put the 1 there, I just did for illustration here. It's actually more preferred that we don't. So, to that end, now that my example's over, we'll just do that. All right, so the quotient of like Powers' law, or quotient law, for any real non-zero values, x, y, and a to the x divided by a to the y is going to equal a to the x minus y. And just like the product law, the bases must be the same. All right. So we've taken a look at the product rule and the quotient rule. Next, we're going to look at the power rule. And the power rule says that when we have an exponent that's raised to another exponent, so like this example, a squared raised to the third power, all we're going to do is we're going to multiply our exponents together. So in this case, we do 2 times 3, which is 6. So a squared to the third power is going to be a to the sixth power. In general, if we have a to the x raised to the y power, it's going to equal a to the x times y. Now, if we consider an example like this, where we've got more than one term inside brackets, and it's raised to an exponent, then this is actually called power of a product rule. And what it says is we're going to distribute this exponent to both terms inside the brackets. So AB in brackets cubed is the same thing, or it equals A cubed times B cubed. In general, any terms in brackets A B raised to the exponent x, we're going to just distribute that exponent to every term inside the bracket. So a to the x times b to the x. Finally, we're going to consider when we're looking at a situation like this, power of a quotient rule. So here, what we can see is we've got two terms inside brackets, and it's division this time. So a divided by b, and all that is going to be squared. Same idea. We must distribute that exponent to all the terms inside the bracket. So if we have bracket a divided by b, close bracket, squared, that's going to equal a squared divided by b squared. So in general, whenever we have a divided by b in brackets to the exponent x, that's just going to be a to the x divided by b to the x. All right, so we're going to simplify a couple expressions here. So here, let's just get back to the right format. There we go. We have x to the fourth times x cubed. And in this case, we have the same base. We're multiplying our exponents. So what we're going to do here is we're going to have our common base. It's going to be raised to 4 plus 3. So x to the seventh according to the product rule. So when we're multiplying two exponents with the same base, we add the exponents. So x is our common base. 4 plus 3 is going to be 7. This one's the quotient rule. Whoops. And in the quotient rule, it tells us we need to subtract our exponents if we're dividing two exponents with the same base. Here, same base. Oops, didn't need fractions. Y to the eighth divided by y to the sixth. So that's going to be the same as, actually, let's do this. It's going to be the same as y to the 8 minus 6. Or that's just going to equal y squared. So dividing two exponents with the same base, we're just going to subtract our exponents. So in this case, our numerator exponent was 8, denominator exponent 6. 8 minus 6 is going to give us 2. So we're left with y squared. A final one here, and this is the power rule. So remember in the power rule, if we've got an exponent and it's raised to another exponent, we're going to end up multiplying those exponents. So we're just going to go here. Doo, 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 doo. So our base is z, and in this case, that means 3 times 4, which, if we do that, 3 times 4, of course, is going to give us 12. So z to the third raised to the fourth power, multiply our exponents. 3 times 4 gives us 12. And that's exponents. That's what we're going to look at right now. And we're going to come back in another video and look at the distributive law or FOIL. See you soon.